Hey everyone, welcome back to the channel. Before we dive into today's truly mind-bending topic, I just want to send out a massive wave of good vibes to all of you watching. Seriously, wherever you are in the world, I hope you're feeling fantastic, taking good care of yourselves, and surrounded by positivity. Health is everything, so look after it. Okay, strap in because we're talking about something straight out of a sci-fi movie, but it's happening right here on Earth, in the swamps of the Carolinas, the Venus flytrap. You know that plant, the one that looks like a green mouth with spiky teeth? Yeah, that one. But here's the kicker, the thing that absolutely blows my mind: Venus flytraps don't just snap shut when touched. They actually count how many times something touches their trigger hairs before they decide to close. Let that sink in for a second. A plant counting. It sounds impossible, right? But it's real, and it's one of the most incredible survival tricks in the plant kingdom. Forget passive greenery, this is active, intelligent-seeming behavior, and it's all about making sure dinner doesn't escape while not wasting precious energy on false alarms. Imagine you're a Venus flytrap. You live in nutrient-poor, boggy soil. You can't just suck up all the good stuff you need from the ground like most plants. To survive, you've got to catch insects. They're your vital source of nitrogen and other nutrients. But catching a fast, wriggly bug with a leafy trap isn't easy. You need a system. A really, really smart system. That's where the counting comes in. Inside each of those little traps, there are usually 3 or more super-sensitive trigger hairs. Think of them like tiny tripwires. If something bumps just one of these hairs once, nothing happens. The trap stays wide open. But if that same hair, or a different one nearby on the same trap, gets bumped a second time within about 15 to 20 seconds. Wham! The trap slams shut incredibly fast, faster than you can blink. But here's the crucial part, it doesn't start digesting yet. It's just closed. It's like the plant has locked the doors but hasn't called the police. Now, why the delay? Why doesn't it just close and start eating on the first touch? Well, think about its environment. Raindrops fall. Bits of debris blow in the wind. A stray piece of grass might brush against it. If the trap slammed shut and started its super energy-intensive digestive process for every single little bump, it would be constantly wasting energy on false alarms. It would literally starve itself trying to digest raindrops or dust. That's a death sentence in a place where energy is scarce. So, evolution came up with this genius counting mechanism as a filter. The first touch is like a warning, hey, something's here. It primes the trap, gets it ready. If nothing else happens within that short window, the plant assumes it was just a random event, a raindrop, a piece of dirt, and it resets. No harm, no foul, no energy wasted. But if that second touch happens quickly, it strongly suggests that whatever is inside isn't just falling debris, it's moving. It's likely an insect brushing against the hairs as it crawls around or struggles. 2 touches signal probable prey. But the counting doesn't stop at 2. Once the trap is closed, the plant isn't done counting. This is where it gets even more amazing. The struggling insect inside, trapped but not yet being digested, will naturally keep thrashing around. It will keep bumping those trigger hairs over and over again. The Venus flytrap is literally counting these additional touches. It needs to reach a threshold, usually around 5 touches in total, to confirm beyond a reasonable doubt that it has caught live, struggling prey worth digesting. Only when that 5th touch, or so, is registered does the plant commit fully. It starts pumping out digestive enzymes, essentially turning the inside of the trap into a stomach, dissolving the insect and absorbing the precious nutrients. If the struggling stops before reaching that higher touch count, maybe the insect died quickly, or it was something too small or not nutritious enough, the plant senses the lack of continued stimulation. It might hold the trap closed for a day or so just in case, but if the touches don't reach the required number, it will slowly reopen, saving its energy. Whatever was inside, dead or alive, can crawl or fall out. The plant avoids wasting energy digesting something that isn't a worthwhile meal. So, how on earth does a plant count? What's going on inside those green leaves? It's not like it has a tiny brain or fingers to count on. It's all about biology and electricity. Yeah, you heard that right, electricity. When something bends one of those trigger hairs, it physically disturbs special cells at the base of the hair. This disturbance causes a tiny electrical signal to fire, kind of like a miniature nerve impulse. This is called an action potential, similar to what happens in our own nerves when we feel something. That first electrical pulse doesn't trigger the trap to close, but it does set the trap into a primed, alert state. It's like arming a security system. If a second pulse happens within that critical 15 to 20 second window, it trips the mechanism. Special cells along the midrib of the trap react incredibly fast. They rapidly change shape, shifting water internally. This causes the trap halves, which were convex, curved outwards. When open, to suddenly snap into a concave, curved inwards, position, slamming the trap shut. The spiky edges mesh together, imprisoning the prey. The counting of those subsequent touches after closure works the same way. Each struggle that bends a trigger hair sends another electrical pulse. The plant isn't consciously counting 1, 2, 3. Like we would. Instead, these pulses act as signals that build up. Think of it like filling a bucket. The first 2 pulses fill the bucket enough to trigger closing. The next few pulses, reaching that threshold of around 5, fill the bucket enough to trigger the production and release of the digestive juices. It's a biochemical cascade initiated by the cumulative electrical signals. More touches mean more signals, confirming vigorous struggling and justifying the energy cost of digestion. This system is incredibly energy efficient. Digesting an insect takes days and a huge amount of the plant's resources. By requiring multiple confirmations, first 2 touches to close, then several more to digest, the Venus flytrap ensures it only invests that massive energy when the payoff, a nutritious meal, is almost guaranteed. It's a perfect adaptation to its harsh, nutrient-poor environment. This counting mechanism highlights something truly profound about life. We often think of plants as passive, simple organisms. But the Venus flytrap shows us complex behavior, sophisticated sensing, and decision-making based on sensory input, all without a nervous system or brain as we understand it. It's a reminder that intelligence and complex problem-solving can evolve in many different forms. The plant isn't thinking, but its biology is exquisitely tuned through millions of years of evolution to respond in a way that mimics intelligent decision-making for its survival. It has evolved a way to distinguish between random environmental noise and actual food using a basic form of counting triggered by electrical impulses. That's pure, elegant biological engineering. Next time you see one of these fascinating plants, remember the incredible internal drama happening. It's not just waiting for food. It's actively sensing, counting touches, making calculated decisions about when to strike and when to conserve its precious energy. It's a tiny green predator with a built-in security system and a cost-benefit calculator, proving that nature's solutions are often far more ingenious than anything we could invent. Pretty cool, right? Thanks for exploring this amazing bit of nature with me today. Stay curious,